In this video, I'll be working through the question you can see on the screen from the Cambridge A-Level Maths Paper 1. Specifically, it's Paper 1-1 from the winter exams in 2023. If you're looking for a different question from this paper, there should be a link to a playlist with all the questions below this video. I'm doing this on a whiteboard. Hopefully it'll be like you're used to your teacher doing. And if you do find this or any of my other videos useful, I'd greatly appreciate it if you like, subscribe, or even share it with a friend that's doing the exam this year or next. In question 6, we're given an image that looks roughly like this. The image in your paper is much better quality than mine. So like mine's a good bit off. For example, this length should be the same as this length, whereas my drawing doesn't look like that. Anyway, it's basically a circle with center 0, goes around here, and then cut out of that circle another circle with center C that goes through A, O and B, and it cuts out this shape, leaving us this top part that's shaded in. I won't shade it in here because it looks terrible on a whiteboard. Yeah, and that's the shape we're left with, and we're asked 3 questions about that. Now here's the important thing about the questions. Part A and B each only have 1 mark. Now that's a bit of a clue that they're quite easy to do. The answer is nearly just, oh, there's the answer. But I will warn you, I would say a lot of students didn't get Part A and then weren't able to get Part B. Well, you still might have been able to get Part B, but then weren't able to get Part C. And that sometimes happens. I'll try and explain my thinking as I go through it, but sometimes it's just, oh yeah, there's the answer. Your teacher does it, and sometimes you're sitting in a class going, yeah, but I couldn't have done that. All I'll say is practice. More papers, more questions, practice, practice, practice. You will start seeing those obvious answers. Okay. Part A, it asks you to find, it tells you, given that the angle ACB, so that's this angle in here, the whole bottom of this, given that that's K pi. So basically, given it's K pi, what is K? What they're really asking there is, what's this angle? It's a strange way. I hate how they ask that. What they're basically asking is, what is this angle down here? Give your answer in the form of K pi. And there's only 1 mark, so you should be able to just go, ah, I know the answer. So what is it? Here's my clue. When you're dealing with circles, the answer is usually about the radius. Where is a radius that you've missed? They've given you a couple of radius. From O to A is the radius of this circle. From C to A is the radius of this circle. There's other radius. From C to O is the radius of this circle. From C to B is the radius of this bottom circle. From O to B is the radius of this top circle. They're all OR. There's lots of ORs everywhere. Let me draw one of these triangles again. That's OR, OR, and OR. What do we know about this triangle? It's a equilateral triangle. That means, what's this angle down here? It's 60 degrees, or in radians, it's pi over 3. That angle's pi over 3. Both of them together, let me draw that again. Both of the angles together is 2 pi over 3. And that's the answer. The answer for this angle is 2 pi over 3. They told you it's also K. That is equal to 2 over 3 pi, I guess. Or what they wanted is K is equal to 2 over 3. Now you could have just looked at this and gone, well, that's 60 degrees, that's 120, or in radians, 2 over 3 pi. There's your answer. Okay, let me rub some of this out and I'll talk about part B, which again, you can look at and go, ah, there's the answer. So for part B, they ask us, what is the perimeter of the shaded region? So that's starting here, all the way around, and then going in like this. What is the perimeter of that region? Again, there's only 1 mark. And honestly, I didn't see the trick. There's a trick to answer it. how I tried to answer it, while I was doing it, I was like, this has to be wrong. This is more than 1 mark. So how I did it first, really quickly, is we can get the perimeter of segments. So starting here, I'll draw this segment, something like that. That's CA all around, way around to B. Yes, C, A, and B. I can get the length of this here. We have formulas for that. Let me throw it up on the board. The formulas they give us for circles and segments in radians. The formula for this is L is equal to or theta. And we know theta, we just found out theta is 2 over 3 pi. L is equal to or 2 over 3 pi. And another segment, this bigger one, is this segment. I still want to find L. Now I need this angle. This angle is, the whole circle is 2 pi. This is 2 over 3. Remember, this is the long way. This is not the easy way to do part B. So this is 2 pi minus 2 over 3 pi, which is 4 over 3 pi. So the length of this part is L is equal to or 4 over 3 pi. Add these two together. This length plus this length is the total thing. Add them together, I get a 4 over 3 plus 2 over 3 is 6 over 3, or 2, or pi. Now at that point, when I did this, I went, wait, 2 or pi, that's just a circle. And I was like, oh, of course. Have a look what they've asked us here. The length of this plus the length of this. But look what would happen if you folded this over. Now my drawing's too bad, but if you have this question on a piece of paper, you could literally fold it over, and look what happens. This circle comes down here and fills this in. So the answer was obvious from the start, that it's a perimeter of a whole circle, and it's the radius r, so it's 2 pi r. If you did it a long way, you still got full marks, but yeah, the answer to B is 2 pi r. Okay, let me rub this out and I'll do part C, and that's the first question that's actually hard. It has, I think it's 5 marks. Okay, part C asks us to find the area of the shaded region, which again is the top half here. And they give us a little hint. They say the answer is in terms of pi, or, and square root of 3. Now pi and or, that's obvious. Any answer for an area of a circle will be pi and or if they haven't given you or. The square root of 3 is a nice little clue. It tells us as we're doing it whether we're right or not. If your answer doesn't have a square root of 3 in it, you're wrong. Okay, so how do you do this? This is actually quite a hard question. It's 5 marks. It's really tricky, and it's quite tricky to explain how I did it. Let me draw lots of pictures to show how I did it. What I would like you to think is, what can you find? So the things I know how to get the area of that are important here would be a circle and a segment, and a little sneakily a triangle, which there are triangles there. So I can get the areas of all them. So the secret here is to try and take away shapes to get this shape. Like it would be nice if we could get a big circle minus this circle, but it's not a circle down here. It's only part of a circle, and it's not even a segment. It's a circle with little bits on it. That's too difficult to do. Like, I would like it to just be one circle minus a circle down bottom, but unfortunately that would leave the top part we're looking for, sure, but it would also leave some sort of minus bottom part that would be some similar shape that's like a minus this, which would be a whole lot of trouble anyway. So no, that's not the right way. But still, you want to think shapes that you know, minus shapes you know, or add shapes together. And the answer here, at least the one I came up with, is to take away this segment. So we understand circles, we understand segments. We can get the area of this, we can get the area of this. The problem is that leaves mostly the shape I want, leaves the top part I want, but it also leaves let's see, two little weird bits at the bottom. Let me zoom in on what it leaves there. It leaves this shape here, and this shape just down here. So I can get the area, I'll do this again later, but the area is just pi r squared, and the area of this would be a half r squared theta. I hope that's correct. Let me have a look. And it is. So we can get the areas of these, but we're left with two of these guys. They're touching each other, but I'll just zoom out so we can see it a bit better. So now the question really comes down to, can we find this area? Because if we can just take that away from this answer. So let's do that. Let's try and find this area. We have a segment minus a triangle will in fact leave this area here, and then I just multiply it by 2. So that's what this question has boiled down to. I've done no maths yet, but I think an examiner would probably give me a couple of marks for drawing these shapes, because this is the idea. Again, we can get the area of this. That's a half r squared. This is r. This was r as well, actually. A half r squared times this angle here. So what is this angle in here? What is this angle in here? Again, part A we talked about, it's 60 degrees. It's pi over 3. It's pi over 3. Minus, and now this triangle. Again, my drawing's terrible, but this is an equilateral triangle. There's probably a convenient formula for an equilateral triangle, an area. I don't know it, but we'll just go ahead and use normal trigonometry. It's a half side by side, which is r squared, they're all the same, and multiplied by sine of the angle, and they're all the same, so sine of pi over 3. So what does this equal? We can put this, we might have to put some of this in the calculator. We get r squared over 6 for this part. This part, sine pi over 3. Put that into a calculator. I'll just double check my notes. You get square root of 3 over 2. And that's good, because remember, we wanted a square root of 3. So we get, for this part, we get a square root of 3 over 2. And this 2, we get r squared, square root of 3 over 4. Let's just put a circle around this guy here. I better rub this out and give myself a bit more room. I'll keep these shapes I have here. It's a shame I had to rub this out, because there's really not that much maths in this. I've just gone and taken a lot of room with a lot of drawing. So let's do all the maths over here. We're going to take pi r squared, sorry my writing here, minus a half r squared. Oh, I don't have the theta in. Remember, theta was this big angle. It was pi over 3 times 2, so 2 over 3 pi. And then we are going to take away 2 of these guys here. Oh, I just realized I'm missing a pi here. Yeah, okay, pi over here. So I'm going to take away 2 of these guys. So minus r squared pi over 3. Let's put a little wall here. And then minus would be plus r squared square root of 3 over 2. And it's a bit of a mess, but we can clean a lot of this up. Lots of things have r squares and pi. In fact, everything has r squared. Take r squared outside. Let's see all the pi's. We have pi here. We have these 2's cancel. We have r squareds out already. We have minus pi over 3. We have minus another pi over 3. So that's pi minus 2 over 3, which is 1 over 3. Pi minus 2 over 3 pi. I'm confusing myself here. Pi over 3 is left when you put these 3 all together. This guy has r squared outside, and we're left with plus square root of 3 over 2. That's as neat as I can get the answer, and just check in my notes which has the answer. I haven't taken r squared out of these notes, but still, that's the same answer. Yeah, this is correct. Full marks here for this. Okay, I hope you were able to follow that. It's It's not an easy one to teach when you try and see the patterns and where they come from. But yeah, if you have any questions, let me know in the comments below. Ask me questions. I'll try and answer as best I can. I hope I explained somewhat. Thanks for watching and have a good day.